Over the years, scientists have continued to unravel many mysteries surrounding the universe, providing us with a new frontier knowledge. Sometimes their discoveries go beyond the limited human comprehension that we get held in disbelief and surprise. And when we thought we had seen it all about the Milky Way galaxy, scientists discovered a zone that is proving inaccessible or hard to identify. However, a team of astronomers led by Daniela Galdiano has recently uncovered a galaxy lurking in oblivion in our very own Milky Way universe for many decades. What could they have discovered, and what will be its implications for humankind? These scientists have just detected something huge that's hidden behind the Milky Way galaxy. Keep watching as we tell you all about it. Firstly, let's briefly dive into our cosmic neighborhood, the Milky Way galaxy. The Milky Way galaxy is a barred spiral galaxy with large pivoting arms stretching across the cosmos. It consists of hundreds of billions of stars, including the Sun. Our solar system orbits the center of the roughly 13.8 billion-year-old galaxy, just as the Earth orbits the Sun. Although Earth lies within the Milky Way galaxy, astronomers need more understanding of its nature compared to other star systems. To understand the galaxy, scientists have made several efforts to peep into it. As put by lead author Professor Lister Staveley-Smith from the University of Western Australia node of the International Centre for Radio Astronomy Research, the Milky Way is magnificent, of course, and it's very interesting to study our galaxy, but it completely blocks out the view of the more distant galaxies behind it. In the Milky Way, we have mediums such as water and gas that obscure the pass-through of light over a long distance. This is coupled with the galactic clutter of planets and stars. All of these add up to an obscure view of the clearer portions of the Milky Way. At the center of the Milky Way is a supermassive black hole millions of times the size of our Sun, making it more difficult to see through it. Behind the Milky Way galaxy lies an uncharted phantom region known as the Zone of Avoidance. It is a blank spot on the map of the universe that comprises approximately 10 and 20% of the night sky. Its view has been long hidden from telescopes because the bulging center of the Milky Way covers it. Because of this, researchers have little to work with, making it difficult to study thoroughly. Now, remember that the center of our galaxy is so dense that it becomes nearly impossible for light to penetrate it. Well, scientists have attempted to look through the zone of avoidance using various techniques and instruments. For instance, the Hubble Space Telescope made its first discovery in 2016 when it managed to glimpse a galaxy. The galaxy, named GNZ11, had been in existence for about 400 million years after the Big Bang. However, it was too bright to see because it forms stars 10 times as fast as our galaxy. Some scientists believe that Hubble's telescope was already at the limit of its capability, which made it difficult to surpass the distance record. It's on this note that the James Webb Space Telescope was introduced in 2018. The James Webb Space Telescope, or JWST in short, captured new baby pictures of the universe. These galaxies are so bright and have just been hiding under the limits of the distance Hubble's telescope can reach. The JWST is equipped with a giant mirror that allows it to detect faint light traveling the universe. With this technology, the telescope could visibly detect what galaxies looked like at the earliest times. In the snapshots captured, scientists also discovered the existence of luminous galaxies even when the universe was still very young. It was at this point that scientists realized that an average galaxy contains about 100 billion stars. Also, it helped scientists to form a new view of the universe's evolution by understanding galaxies at their earliest times. But while the JWST opened up a new frontier by bringing us closer to understanding the beginning of the universe, other galaxies are still hiding under the limits of this technology. So far, only radio observations from the CSIRO's Parkes Radio Telescope, a 64-meter radio telescope located in Australia, have allowed astronomers to see through the thick layer of dust and stars. Yet the observations failed to provide enough evidence to make scientific conclusions. With this in mind, researchers had to develop new ways to see through the clutter by building innovative technologies that can help them survey large areas of the sky very quickly and make discoveries at a greater rate. They realized they could only explore the Milky Way better if they shifted the light spectrum from the visible to the infrared zone. Thus, they built different instruments, including telescopes, to detect infrared radiation. Remember that we said that the Milky Way is a dense region. The vast clouds of gas and dust in the region cast a veil over the plane of the Milky Way, making it nearly impossible for light to penetrate it. However, new telescope designs are powerful enough to penetrate dense clouds or cosmic fog because they utilize lower frequency infrared light. An example of such a telescope is the James Webb Space Telescope, which can make near-infrared observations, unlike the Hubble Space Telescope. When a series of infrared surveys were carried out on the zone, it was discovered that it's home to thousands of individual galaxies. Yet astronomers had no idea of the possibility of having anything like what was lying there. Recently, a team of researchers from the National University of San Juan in Argentina probed the zone of avoidance with the European Southern Observatory's Visible and Infrared Survey Telescope for Astronomy, or VISTA, in Chile. The study was carried out with several state-of-the-art astronomical instruments placed in various southern hemisphere locations. The team discovered several dozen objects in the zone of avoidance with this instrument's aid. One such discovery is a large extragalactic structure that is nothing close to any kind humans have ever seen. This means that the extragalactic structure, an object or collection of objects far beyond the Milky Way galaxy, has always existed. It had only not yet been identified. A 2021 study had earlier revealed the possibility of having new extragalactic sources in the zone of avoidance. However, the researchers could not confirm their suspicion as it was merely based on photometric techniques. But we will take the win. At least now we have a glimpse of what lies on the other side of the galactic core. The huge structure seems like a large cluster of galaxies drawn together by a shared center of gravity. To further understand the infrared imagery of the structure, the team zoomed in on the region with the aid of a near-infrared instrument known as Flamingos 2. At this point, they discovered that the galaxies are galactic, that is, located far beyond the Milky Way. They then checked whether the lines of the elements in their spectra were shifted to the red side. This is known as a redshift, which, according to Hubble's law, can determine the distance and velocities of objects in space. Using the VVV survey, the team estimated the galaxies that make up the massive extragalactic structure to be at least 58, and the redshift to be approximately equal to 0.22, indicating that they are located at a distance of 2 billion light-years away from Earth. The VVV survey is a project sponsored by the European Organization of Astronomical Research to study the stars with infrared emissions rather than visible light. Such emissions can penetrate through the bulge that covers the galaxies and send data to instruments set up on Earth. The results reveal about 5 galaxies about 3 billion light-years away, which implies that they are far older than the Milky Way. The team thinks that these galaxies are part of a much bigger cluster. Also, they are able to show that the overdense region shares many qualities with other known galaxy clusters. The group of galaxies is known as the VVV GCI-B J1-81435-381432, and the team estimated its mass to be 40 to 50 times that of the Milky Way. This was merely in line with what is expected of such galaxy clusters. Similarly, the team estimated the radius size as the distance between the Milky Way and Andromeda, the closest largest galaxy to ours. It is important to note that the precise value of the radius size depends on the universe's rate of expansion. Currently, the number is contentious. This is a result of the so-called Hubble tension. Clusters of galaxies constitute the largest of the universe's gravitationally bound objects. Research indicates that the largest clusters contain hundreds of thousands of galaxies that are bundled together. Unfortunately, scientists have not been able to tell how massive the huge galaxy cluster is because of the vast distance and the number of obstructions between the stars and Earth. And besides, an average galaxy contains stars that run into the 100s of billions. But come to think of it, why are they difficult to find out when they are this close? What could be the mass of hundreds of new galaxies hidden behind the Milky Way? Well, we already discussed this. Our very own Milky Way has been blocking its view. In terms of mass, we have a lot of mass that we cannot tell its vastness yet. This is why we still don't know much about the zone of avoidance yet. Though the discovery of this huge structure indicates that the zone of avoidance is understandable, it will take more observations to know its mass and contents. This will require scientists to use more sophisticated telescopes to penetrate the Milky Way's bulge to take the deepest image of the galaxy clusters. However, in addition, the team suspected that this discovery may help to explain the intricacies of the Great Attractor region. This region has remained a mystery since the discovery of major deviations from universal expansion in the 1970s and 1980s. The Great Attractor is an unidentified anomaly that continues to draw our galaxies and clusters towards it with a gravitational force equivalent to 1,000,000 billion suns. Professor Lister Stavely-Smith said in a press release, "We don't actually understand what's causing this gravitational acceleration on the Milky Way or where it's coming from." He also said that the region has a few large collection of galaxies that can be referred to as clusters or superclusters, and the Milky Way is moving towards them, that is, the clusters, at a speed that is over 2 million kilometers per hour. Initially, the team's original goal was to study the Great Attractor to find out what it is, how it is formed, and how it is structured. However, it turned out to be an exploration into an unknown region. Well, it turned out to be a great addition. We've learned some new details about the Great Attractor. For instance, the new structures discovered will help explain the Milky Way's movement. But with more research, observations, and advanced sensitive radio and infrared telescopes, will scientists ever be able to unravel the mysteries of the formation of the cosmos? Let us know your take in the comments.